Nestor sir, hello.
Yes, ma'am.
Sir, we'll start within 3 minutes.
Okay, ma'am.
Ma'am has joined now.
Yes.
Nestor sir, can we start? Or we wait for 5 minutes?
No, ma'am. We can start now.
We can start.
Ma'am. Ma'am has joined the session. Welcome, ma'am. Ma'am, we start the session now.
Okay, Dipali. Good afternoon, everyone. It's my pleasure to welcome you all to this exciting and enriching faculty development program on AI and its application in research. I, Professor Suptalini Patnaik, working as Assistant Professor in Electronics and Telecommunication Department, be the session coordinator for the first session. We are fortunate to have Dr. Shaila Dinkar Apte ma'am, our esteemed session expert, with us today. It's my distinct honor to introduce Dr. Shaila Dinkar Apte ma'am, a visionary academician, innovator, and entrepreneur. Dr. Apte ma'am holds a PhD in electronics engineering from Walchand College of Engineering, Sanli, and has guided 11 PhD scholars over 65 postgraduate students. Her illustrious career includes leadership role, impactful research, and groundbreaking. Dr. Apte ma'am is the founder and CEO of Anubhuti Solutions Pune, a pioneering organization offering cutting-edge audio and image processing solutions used extensively in forensic science labs across the country. With over 45 years of professional experience, she has left an incredible mark on the field of electronics and digital signal processing. Dr. Optimum owns 4 trademarks for the audio products. She has 6 patents in speech and audio processing technology. Dr. Optimum has also authored 5 highly regarded books with international publishers and numerous international publications reflecting her unparalleled expertise. Her potential is limitless and no words can truly express it. Let's give a warm welcome to Dr. Shaila Dinkar Apte ma'am as she enlightens us on the topic artificial intelligence for speech forensic. I request ma'am to take the control of the session. Nesta sir, please make ma'am host so that she will stay at the screen.
Yes,
Thank
ma'am.
you ma'am.
Done, ma'am.
Welcome you ma'am. Hello ma'am. Hello ma'am. Nesta sir.
Yes, ma'am.
Ma'am is here now, but ma'am voice is not audible. The screen is visible.
Ma'am, kindly exit the screen share and unmute and then screen share.
Yeah, ma'am.
You, okay. Now it is, I think I am audible now.
Yes,
Yes,
ma'am.
ma'am.
Yes,
Yes.
ma'am.
Yeah. Thank you so much. Yeah, I will share the screen now.
Yes, ma'am. Welcome you, ma'am.
Yeah, is it visible?
Yes, ma'am. Is it
Yeah,
visible?
yeah. So I welcome you all to this session of forensic examination of and the corresponding audio evidences used for forensic examination. So here also there is a use of AI. So I am talking about use of AI in forensic science. Currently, I am working in forensic science, and the name of my company is Anubhuti Solutions, and we have generated several products which are useful for the forensic examination. And I will first talk about the speech products, and then I'll go to video and image products. I will. I think I'll have to use the
Slideshow, ma'am.
slideshow.
Press F,
Not getting that.
F5, ma'am.
F
F5, F5.
F5. Okay.
Is it working? No, no.
F5. It's Control F5.
Uh, Ma'am, in the top also there is the options, na? Slideshow,
Just
file, new.
I check. I just check. Slideshow. Slideshow from the beginning. Yeah.
Yes, yes,
I hope it's visible now. Yeah. So let's
yes,
start.
yes.
Yeah. So I'm just trying to list out the number of products that we have. First one is audio authentication system, Anubhuti audio authentication, AAA 5000. Then we have Anubhuti speaker verification, ASV 5000. We have Anubhuti speaker diarization, ASD 4000. And we have ANC Anubhuti noise cancellation 3000. So the Anubhuti Solutions is our brand name, and the brand is now getting established. So these are the products as I have already told you. Now let us come to the point. So we want to understand how AI is useful in the speech processing. And what is speech processing? Briefly, I'll first introduce you what is speech processing, how it is done, why it is difficult, and so on. And then we will go to how AI can be useful or AI can be utilized in the forensic domain. So, firstly, let us go through different basics of speech. So, how speech is produced. Let me tell you that we have larynx. So it generates the fundamental frequency. That means inside the larynx, there is one tuning fork, you can say. There is a fiber-like thing, and there are two fibers. Those are vibrating. Those are called as vocal cords. These vocal cords, they vibrate with the fundamental frequency. And then the corresponding excitation passes via the vocal tract, and then the spoken things are heard by others. Okay. So that is how speech is coming out. So how speech is produced? The speech is produced because of the excitation getting convolved with the impulse response of the vocal tract. So it is basically, it is a convolutive signal. It is a convolution, result of convolution of excitation with impulse response of the vocal tract. It is not a man-made signal, it is a natural signal. Means you cannot generate speech. You can synthesize the speech. You have already recorded speech available to you, and using that you try to synthesize the voice. So voice synthesis is different and voice generation is different. Voice generation is not possible up to date. It is not possible and it will not be possible at all. So even though AI is at its top level, we are not in a position to generate the speech. The speech basically, because it is being a convolved signal, it is very difficult to analyze. So if there is some noise also getting introduced in the speech, what will happen is this noise will also be either added up, or it will be multiplied, or it will be convolved with the speech. So noise, isolation of the noise from the spoken words is very difficult. Let us see what are the important speech parameters. The speech parameters, important speech parameters include pitch frequency. As I told you, there are vocal cords, that is fiber-like thing, those act as a tuning fork, and when it vibrates, it generates the fundamental frequency, that is also we call it as pitch frequency. Then we have formants. This is a characteristic of the vocal tract cavity. But what is vocal tract? Under this vocal tract, we have actual vocal tract cavity. We have the mouth cavity, we have the nasal cavity. So all these cavities are connected together and they form what is called as, you can say, this complete thing forms what is called as the vocal tract. And so vocal tract does not simply mean vocal tract. It will include mouth cavity, nasal cavity, and then it will generate some formants. What are formants? Those are the resonating frequencies of this vocal tract. Because it is, you can say, it is a waveguide. It is a sort of a waveguide. There are number of modes for the waveguide, as you may have gone through in theory. You must have studied that there are TE modes and there are TM modes, and these almost infinite modes are available. And because of these infinite modes, there are infinite resonating frequencies. When we track the resonating frequencies called as formants, we track the first few formants. So we are tracking only first 4 or at the most 5 formants. The further formants are not trackable because there is always some noise involved in the speech signal, and because of this noise, the further higher order formants are not trackable. Both these parameters, that is pitch frequency and the formants, they will depend on what word is being spoken. They will also depend on who is speaking. They will also depend on the mood of the speaker. Whether I am in happy mode, whether I am happy, or whether I am angry, or if I want to speak in the aggressive mode, or if I am sad. Accordingly, also these parameters will change. If the speaker changes, the parameters will change. If the spoken words are changing, the parameters will change. As I'm speaking different words. So as the different words are uttered, the corresponding parameters of speech signal will change. And as I already told you, the noise that will be there in the signal, it may be additive, it may be multiplicative, or it can be the convolutive type of noise, right? I have taken a pointer also. I hope it is visible. So hence it is difficult to isolate. So let us see how the classification of the speech parameters can be done. Now, before we go through different parameters, let me tell you that when you are using artificial intelligence, there are some ready tools available which use the artificial intelligence. There are some neural networks, those are already trained. But these already trained neural networks or already trained models, are not useful for the applications because they may be using some parameters from the speech signal which may not be useful for our purpose. So what we'll have to do is we'll have to extract the parameters those are of our interest or useful for our application, and then we'll have to move ahead. So we will have to see what are the different speech parameters those are there. First category is statistical parameters. Then we have spectral parameters. We have different plots. We have spectral features that we can analyze different spectral graphs. We can have formants extraction. We can have IPA symbols, and we can use those. And there can be some other different applications which may be using further speech parameters like log area ratio, and means there are almost hundreds of parameters if you start listing out. Let us first go through the statistical parameters. Statistical parameters, mean and standard deviation, this you already know. What is the mean? It is the mean of all the signal values. But suppose I am speaking now for this session, I am speaking for 1.5 hours. Then how many samples you will have to process? Those are almost infinite. So are you going to add up all these samples and then divide by the number of samples to find the mean? The answer is no. What you will do is you will not actually calculate the mean, but you will estimate the mean. What you will do is you will try to find out the mean of successive segments and then find the mean of all these means. That will be the estimate of the mean of the entire speech segment. You can also find the standard deviation. Higher order moments will include the third order moment, fourth order moment, and so on. The second order moment is standard deviation. Third order moment is skewness or skew. Fourth order moment is kurtosis. Then we also have a harmonics to noise ratio. This will depend on what is the noise in the signal, how many gaps are there in the spoken words. Then it will also depend on whether unvoiced segments are more or voiced segments are more. It will also depend on the speed of talking and all other things. Then we have signal to noise ratio. Then we also analyze histogram to find out certain parameters. So this is in short about the statistical parameters. Then we have, I think I have told you all this, so I will go ahead. So this skewness or skew is a typical parameter, and this skew either can be positive or negative. Now, depending upon whether skew is positive or negative, we can decide whether it is a defect signal or the normal recorded signal. So we have used this parameter called as skewness in the defect detection. So how the skew looks like? So if you are plotting the probability density function, then the probability density function will look like a left skewed as shown in the on the left hand side, or it will be right skewed as shown in the on the right hand side. Right skewed will have positive skew and left skewed will have the negative skew. So depending upon the probability density function nature, you will get the skewness which will be either positive or negative, and this will decide whether the corresponding audio is coming directly as a result of recording or it is defect synthesized. In case of defect synthesis, what they do is they take the actual audio of the speaker, say about some 20 seconds or so, and then they try to capture the speaker's characteristics. And if you are giving a text afterwards, then this text will be converted to the speech, and they'll be utilizing the characteristics those are captured for the speaker, and then it will be synthesized almost like it is spoken by you. So you can say that it will be mimicking your voice, and the person who is not very much familiar to you may feel that it is your voice only. So this is what is called a defect voice. Kurtosis is the fourth order moment, and it deals with the nature of the PDF again means whether it is highly peaked, it is having high peakedness or low peakedness, that is the corresponding peak is flat, or it is a sharp peak. It also depends on the telledness, that how long is this tell is. If the tell is very short, if the tell is very long, depending on that, the value of the kurtosis will vary. This is also being used in the analysis of deepfake synthesized voices. Then histogram is one tool which can be utilized for finding out all this skew, kurtosis and all. We can also find the mean and standard deviation from the histogram. So let us first just briefly understand how to find the histogram. What you do is you find out how many signal values are there. What is the range? So suppose the signal is normalized. The signal values will vary between -1 to +1. So you divide all these signal values into number of bins, and then just go on counting how many number of signal samples are falling in each bit, and then plot a graph of frequency of occurrence on the y-axis and the corresponding bin value on the x-axis, and you will get the plot called as the histogram. Now, what is the use of this histogram? This histogram we have used in speaker identification. We have also used for random signature forgery. Then the statistical parameters taken together, they also reveal the type of the probability distribution function, which will also indicate the nature of your speech signal. This is some sample histogram plotted for some audio. As you can see, it is having some shape, but it is not peculiarly. See, in this case, the corresponding skew means it is the peak is inclined towards right, isn't it? So this is how the histogram looks like. So accordingly, you can find out whether the skewness is positive or negative after just plotting the histogram. Then there is a parameter called as harmonics to noise ratio. It is also called as HNR. It depends on the gaps between the words, as I told you. It also depends on the words, that is voice part, unvoiced part, how many voice parts are there, how many unvoiced parts are there, how many silence parts are there in between. It depends on the noise in the audio, right? It finds the energy in the voice segments of the speech and unvoiced sections of the speech, and the energy in the voice sections divided by energy in the unvoiced sections will give you the harmonics to noise ratio. It can be useful for gender detection and for classification of angry and happy mood. So we have a system called an emotion detection, wherein for discrimination of angry and happy mood, we have utilized HNR, harmonics to noise ratio. It is also useful for gender detection. The value of HNR for males, maximum it goes up to 12, and for females it goes between 13 to 16. It varies mostly. So it is also useful as one of the parameters for gender detection. Then let us go to spectral parameters. Now, why we should use frequency domain analysis? The spectral characteristics, they reveal the frequency contents of the signal. That is, I think everyone knows. The frequency analysis is what is called as spectral analysis. So we are analyzing the spectrum of the signal. The frequency contents are better visible in the frequency domain. So we are transforming the signal from time domain to frequency domain. And because of that, some features which were not otherwise visible in time domain now become visible in the frequency domain. And also another advantage is the energy gets concentrated in less number of coefficients, which allows you to use signal compression. So only the coefficients those are significant will be utilized, other coefficients can be dropped, and only the significant coefficients can be coded using some coding technique. Now, the transfer function once in the frequency domain is known to you, you can analyze it for the stability of the system. So, before the system is actually implemented, one would like to find out whether the system will be stable or not. where will be the poles and zero locations for the transfer function. Accordingly, you can analyze the behavior of the system in the transform domain. So normally, the spectral parameters are found to be useful for many applications. What are the spectral parameters? We use spectral flux, we use spectral roll-off. The spectral roll-off we have also found out, we have found out spectral roll-off to identify the recorder device, whether it is laptop or mobile and so on. We have used centroid, spectral tilt, male frequency, substral coefficient, that is MFCC, then perceptual linear prediction coefficients, etc. There are, it is a long list of parameters for spectral domain. We have to select the parameters and use it. So if we just try to use all the parameters, it is useless. We have to find out, pinpoint which parameter is more important for which application, and then you have to use it. Now, when we use any transform domain, the basis function is important. What is the basis function that is used for the transform? So if we are considering DFT, that is discrete Fourier transform, the basis functions are sines and cosines, as you know, because it is e raised to j omega, right? E raised to j omega is cos omega plus j sine omega. So we have sine and cosine functions as basis functions. Now these sine and cosine functions, all sine and cosine functions, they are orthogonal to each other. And once the basis functions are orthogonal, we get unique representation of the signal. Now why it should be orthogonal? Because we want to get the unique representation. Suppose we are considering the representation of the point in space. We represent it by x-axis, y-axis, and z-axis. We represent the corresponding point by x, y, and z coordinates. What are these coordinates? X-axis is perpendicular to y-axis, y-axis, x and y both are perpendicular to z-axis. So they are orthogonal. Because they are orthogonal, we get unique representation of any point in the plane. And that is how it can be universally utilized. Otherwise, everyone will have his or her own axis, and the corresponding representation for everyone will change. That is of no use. Now, if the multiplication of the basis matrix and its transpose gives identity matrix, then the basis functions are orthonormal. So, if we are getting identity matrix, matrix into transpose of the matrix, if it is giving you the identity matrix, we say that the basis functions are orthonormal. So it can be orthonormal, but orthogonality is a must in order to get a unique representation of the signal. This is some sample wave frequency substral coefficients waterfall. Waterfall means it is a series of plots in a single 3D plot. So we can use plots, like we can use pitch contour, we can use energy contour, we can use form tracks, we can use pitch contour. This pitch contour is utilized for emotion recognition. So in case of high pitch, if it is a hat type contour, then it identifies that it is angry emotion. And if it is inverted hat type, it identifies happy emotion. So pitch contour is basically a better parameter that is utilized for emotion detection. It is also utilized in sad emotion. In case of sad emotion, the pitch contour is a flat contour and it is having lower value. The energy contour can also be utilized for speech recognition or the word recognition. Formants are specially used for speaker verification if the text is the same. Now, I'll tell you one interesting story about energy contour. Once when I was teaching in Walton College of Engineering, normally the good students, means those who are technically sound, they used to come to my batch because they wanted to take some challenging task and do it. But the other faculty member, they did not like it. So once it was decided that the batch will be allocated to you, you will not select the batch or the batch will not select you. So they just randomly did the selection and one batch of students was allotted to me. I said, okay, no problem. those students came to me and they were saying that, madam, we are ordinary students. So if you give us some complicated task, we will not be in a position to complete it. So I said, never mind, I will not give you the complicated task. I'll give you simple tasks. So I gave them the speech recognition task. So firstly, they were afraid. I said, no need to get afraid. You can also do this because I'm simplifying the matters and giving you the task which is already simplified. So what I did was I asked them to draw the energy contour for every word. And based on that energy contour, I asked them to recognize the speech. So they had recorded some 100 words. That was, of course, in one person's voice, because if you want to recognize the words for any person, then it would have been little difficult. So I said, let us consider the same speaker, and he uttered 100 words, and then we could successfully categorize the spoken words using only energy contour. So only a simple task can work if you beautifully utilize it, right? Now, there are ways to find a pitch frequency. How to find a pitch frequency? There are standard algorithms. One is called as autocorrelation method. Another is called as AMDF method, average magnitude difference function method. So it gives the value of the pitch period in terms of number of samples. So normally the pitch is calculated in terms of number of samples, and then you convert it by taking 1 upon the number of samples to get the frequency, right? Of clean signals, the pitch frequency can be accurately extracted, but there are problems when the noise is mixed up. So for forensic domain signals, it is very difficult, highly challenging to extract the pitch also. So this pitch statistics is normally used for speaker identification. It is also used, histogram is also used for speaker identification, but these are not the only parameters. These can be one of the parameters, right? The challenge is there in the forensic domain, because for the forensic domain, they get some audio which is recorded by police, or they get some audio which is recorded by some person in public. So it is very noisy, and because of that, extraction of the parameters is little difficult. So this is some typical waveform showing the periodic nature. So this is the voice part of the signal. In the voice part, you can see that it is repeating after some fixed number of samples. Depending upon which vowel it is, see here in between, it is a mixed vowel. So in that case, the fundamental frequency or the repetition frequency is different. Here the repetition frequency is different. Here the repetition frequency is different. Now, what is voice pitch? Voice pitch is one wherein you see the periodic repetition of the waveform, as we have seen just now. And we can see that after number of samples, the signal will repeat itself, and then it will be called as the pitch period, and it will be measured in terms of number of samples, as I have already told. Pitch frequency in seconds. Pitch period will be first found out in seconds, and then we calculate the number of samples into 1 upon fs, that is sampling frequency, to get the fundamental frequency. 1 upon fundamental frequency is 1 upon pitch period in terms of seconds. So this is a sample plot of voice pitch. Here you can clearly see that every particular repeated signal has a typical nature, and it repeats after some constant interval. So when you see the repetition, it is definitely the voice pitch. I will not go through the different methods. There is some autocorrelation method. There is also algorithm called as the AMDF method. So I think I will skip this because it's not very much important for our discussion. Then there is what is called as pitch contour, means how the pitch varies from one point to another. So if you take the entire sentence, you will get the contour for the pitch. So pitch varies like this, it varies like this. So This periodic pulse train, which acts as excitation, is what is called as the pitch. So if you want to track the pitch over the entire voice segment, we find that there is some variation in the pitch. And this contour variations in the pitch period are termed as the pitch contour. This pitch contour is also utilized as a feature in the speech recognition. Speech emotion recognition also can be done using the pitch contour. As I said, you will get the hat type nature of the pitch contour, or you will have inverse hat type structure for the happy mode. So it can also be utilized for speaker verification tasks. Then we can also have formants utilized. These formants are normally calculated using the substrum. Why using the substrum? Because sometimes the fundamental frequency and the first formant, they overlap. That is why in order to isolate the fundamental frequency and the formants, we will have to go in the substral domain. So what we'll have to do is, we'll have to take the signal, we window it, because we cannot process the entire signal at a time. We will take 20 milliseconds of the signal. That segment will process. Then we take next 20 milliseconds and so on. So we first take FFT, then we take log, and then we take inverse FFT. And after we take inverse FFT, see, we have taken FFT and inverse FFT, but we have taken log in between. So we go in the substral domain. And then we have to do the substral windowing and take FFT to get the formants, because we will get the, this is the graph that you get after substral windowing. So the peaks, corresponding peaks, we have to track. This will be the first formant, this is second formant, but not really easily visible, then third formant, fourth formant, and so on. So the formants are nothing but the corresponding peak positions of this particular substral graph. Now, human ear characteristics are really wonderful because they respond to what is called as logarithmic scale. And this logarithmic scale is called as male scale. There is also what is called as bar scale. So either you utilize male scale or you utilize bar scale. And when we get the substral coefficients using the male scale, it is called as MFCC, male frequency substral coefficients. And because our human ear responds to the logarithmic nature, the corresponding MFCC will give better results rather than normal substral coefficient. So we'll have to use male scale for the frequency. And it is found that it gives good results as compared to the normal scale, means normal linear frequency scale. We also can use frequency spectrum, that is, we can use the DCT domain, DFT domain, we can also use wavelet transform domain. So sometimes wavelet transform is useful, sometimes the DCT is useful, and sometimes Fourier transform is also useful. So it depends on what type of application you are having and how you are utilizing it. Okay. There are several parameters. As we have just seen, there are several parameters. And which parameters are to be utilized for which application, that one has to decide. And that is one's intelligence. So it is your intelligence to segregate and find out which parameters are important for your application. And whatever intelligence that you have gained, you have now to transfer it to the machine. And when you transfer your intelligence to the machine, it is called as artificial intelligence. So in order you feed artificially the intelligence to machine, your intelligence must be high, otherwise you cannot feed it. So it all depends on your intelligence finally. Only thing is, when you feed the intelligence to the machine can do the repeated task using the artificial intelligence. So septum evaluation, how you do it, how you avoid the overlapping of first formant and the fundamental frequency, that can be done using the septal filtering. So I will not go through the details of this. I think I will skip this. Okay, so we have one system called as speaker diarization. Speaker diarization. This diarization word may be new to you. Speaker diarization means sometimes police gets some audio and this audio has number of speakers. So it is not that only one speaker is speaking in that audio. There are 3-4 speakers speaking in the audio. So in order to verify the speaker, the first task is to isolate the speaker stocks. The isolation of speaker stocks is what is called as speaker diarization. So from the audio, if there are 2 speakers, I will have to separate out the audios of 2 speakers and put it in a separate audio file. And then I can use some parameters, those are useful for me according to my intelligence, and then I will segregate the speaker's task and then I can verify the speaker. But to segregate the speakers, I'll have to use some parameters. So normally, commercially, we are using I vectors or D vectors to isolate the speaker stocks. There can be 3 speakers, 4 speakers also. In that case, the things become more and more difficult. Now, in case we have a system which has unsupervised speaker diarization, means once we give the audio to the system will first try to find out on its own how many speakers are there in the audio. If there are 2 speakers, it will isolate the 2 speakers. If there are 3 speakers, it will identify that there are 3 speakers and it will isolate the 3 speaker stocks or 4 speaker stocks and like that. So this unsupervised speaker diarization, no one has. It is only our Anubhuti Solutions is giving this type of solution, that is unsupervised method for identifying how many speakers are there in the audio, whether it has 2 speakers or 3 speakers or 4 speakers. Also, 3 speakers separation, 4 speakers separation, and more than 4 speakers isolation is not possible yet, but we made it possible and we can have the diarization for almost any number of speakers. So we have tried it for 5-6 speakers also, it is working fine. So for that, sometimes we use what is called as diarization with profile. Means for every speaker, we select 1 second interval and specify that it is speaker number 1, another 1 second and specify that it is speaker number 2, another 1 second and specify that it is speaker number 3, and then give a command called diarization with profile, and it diarizes the speaker stocks. So this is working up to even 5-6 speakers in the audio. So this is one sample that I am showing, speaker diarized output. So here, this particular segment is spoken by 1 speaker. This is spoken by another speaker. So our system could properly isolate 1 speaker's talk from the other speaker's talk. This is what is called as speaker diarized. This is actual case sample. This is the actual case file from the client. And this is for this is what you can say, it is for the customer. One customer care is asking and the client is speaking. So talk between customer care and the client. Actual customer talk is there. We also have forensic speaker verification and identification, which is format based. Means forensic speaker verification means what they do is they isolate the words. So given the speech signal, what they do is they first isolate the words. From the words, they automatically find out the formants in the vowels and then try to match. So police gets hold of one audio which is supposed to contain the culprit stock. Then the culprit will be caught and he'll be presented before the court, or maybe they just try to take him in the forensic lab and get his voice recorded. They ask him to utter the same words those are found in the corresponding culprit's audio. And then what they do is they try to match the words in one question audio and the recorded audio. So it is what is called as words matching. And this word matching is done using the formats. So in this case, we extract F1, F2, F3, and F4, and then use different matching strategies depending upon which type of recording it is, and then we try to match the speakers. So in this case, we are not using pitch frequency, we are using formats. Why pitch frequency is not used? Because pitch frequency cannot be properly tracked for the noisy speech. And in case of forensic domain, always the speech is noisy. So pitch frequency, mostly it is not useful. So they use what is called as formants. So they calculate LPC derived formants, and using these formants, they try to match the formants on one side to the other. And normally they try to use same words, means whatever police has grabbed the audio, same words the culprit is asked to utter, so that when you are comparing the same words, the formants will definitely help you to identify whether it is the same speaker or not. And if the percentage of words those are matching is higher, the speaker will be confirmed. They will say that yes, he must be the same speaker. If only few words are matching, then they do again the auditory analysis, and then they can discard and say that no, the speaker is not the same. Normally, F1 and F2 is given more stress rather than the F3 and F4. We have also given AI-based verification. AI-based verification works on the entire sentence. I'll complete later on, I think. So I will see how the vowels are matched in from the one word to the other. Right. So this is the this is some word that I am showing, and in this case, this is complete vowel part. Now, in this vowel part, how many vowel segments you will get? That is pitch period segments you will get. You will get many pitch period segments. So this kind of word is there on one side. This is the question audio. We will also have the word that is actually recorded, and then we match the frequency formants here and the formants on the other side. So how many segments we get for every particular word? We get many segments. So there is a matching is possible. So this is some 10-second segment. So we take 10-second segment and we analyze what will be the formant. So for each pitch period, we try to find out the formants and try to match it on the other side. Use of window for LPC spectrum. So what we do is, we cannot take the entire word. So what we do is we pass it via some window. Normally, you must have studied the different windowing techniques. Normally, Hanning window is preferred, because Hanning or Hamming window, the shape of the window is such that it is same in the frequency domain and time domain. So there is no spectral leakage, as we say. Sometimes we can also use any other window also, but normally we prefer Hanning or Hamming window. There is no need to downsample the signal for analysis, because downsampling will definitely eliminate the high frequency contents. So normally we take it as it is. This is speaker verification. So this is one word that is recorded. So you can see that this is quite clean. And this is the question word, which is quite noisy. So you can, from the waveform only, you can find out that this is the noisy, means it must be the question word. And this is very clean, means it must be the control word, that is actually recorded word by the culprit. Then they find out the format. So this is the LPC. They have found out the LPCs, the formats for entire word, formats for entire word here. And then we try to match whether at this point, you can see that at this point where the cursor is, the corresponding format here is 417, here format is 420, F2 is 1050, it is 1040, 2577, 2576. Right. So here the formats match within some tolerance. So for every point, they try to match it on the other side. So how many points are matching and whether the corresponding word matches or not. And using the word matching, the speaker verification is done. This is completely automated system developed by Anubhuti Solutions, and it is very much welcomed by the forensic science labs. Sometimes what happens is the culprit will say that I will not utter the same words. So what may happen is the police may have got the culprit's voice, which is in Hindi. Then culprit, when he is asked to speak out something in front of computer, he will not utter the same words. He will not utter in the same language also. He will speak some other language. Then there's a problem for the forensic science labs to find out how to match. So we have developed one more system, which is called as forensic speaker verification. But in this case, it is automated system. It is not manual method. It is the automated method. So it is text independent and speaker independent verification. And this is what is called as the automated system. Here the culprit can utter any sentence and in any language. Still we can verify that he is the same speaker. So in this case, we are using many parameters, like we use MFCC, we use I vector, we use D vector, we use X vector also. And we extract the embeddings. That means we extract, I will tell you, we extract 192 point vector on one side of the audio and 192 point vector on the other side of the audio, and then we try to match it. And you can see that the corresponding speaker is verified, even though he is not uttering the same word, even though he is not using the same language, still the speaker gets verified. Now, there is also text dependent mode provided. So if the speaker is uttering same word, then yes, we can use the text dependent mode, which uses the formats, as I already told you. So it automatically generates the PDF report, and the matching points are also displayed. We can also provide the word report. And so for the case, when the case is there with the forensic science labs, they require something like 8 to 10 days to solve the case. So in 1 month, they will solve maximum 2 or 3 cases. But there is high pendency because there are a lot of culprits in our society. So lot of cases, and the cases are pending. So we have generated a system which is automated system, and if they have extracted some 50 words from the utterance of the culprit and from the utterance that police has grabbed, what they do is they try to match all these 50 words one after the other. So the first word will be matched, then second will be matched, third will be matched, and it will try to find out the formats and try to find out whether the word is matching or not. So it will just go on completing it for 50 words, and the complete work is done in just 10 minutes. Complete matching is done in 10 minutes, and further 5 minutes it takes to generate the automatic report. So actually they can do it, they can just do the complete case in 15 minutes, but they will have to do some manual work also for extracting the words. That facility also we have given, but it takes some time for auditory analysis, extraction of the words, organizing the corresponding folder for analysis and so on. But actually, I can say that the 7 days work is reduced to 1 day work. So actually, people are afraid because whatever 3 cases they used to solve in 1 month for whatever salary they are getting, big salary they are getting, they will have to solve now 30 cases. So they are actually reluctant to use our system. That is a sad story. But okay, now it's picking up. The higher authorities are compelling them to use the tools. They have to use the tools, and sometimes what happens is when we try to find out how many words are matching, say 50 words they are comparing, out of 50 words, say 25 words are matching and 25 are not matching, then you again are in dilemma whether to declare the speaker as the same speaker or not the same speaker. So in that case, what they do is, instead of using the words, what they do is they use the entire sentence, and then they use automatic method, as I told you, using the X vector, I vector, and the D vector. And then they try to match by extracting 192 point vectors, 192 point parameters on either side, and then they try to match and then find out the probability of matching. If the probability of matching goes above 90%, then yes, the speaker is matching. So this is one additional test, which is AI-based test. AI-based test means we have provided artificial intelligence to the system that if using X vector, D vector, and I vector, that is using 192 point analysis, if they are getting probability which is more than 90%, then the speakers are the same. So this is how the artificial intelligence is inserted into the system. Similarly, we have text dependent and text independent mode. In case of text independent mode, as I said, we are using I vector, D vector, and we are calculating 192 points or 192 parameters, you can say. This is called as the embedding vector, and then we try to match it. This also automatically generates the report. We also have emotion detection system. This emotion detection system, see, emotion detection means if you know how I normally speak, then if I am speaking with high pitch, then you can recognize that madam is angry, her pitch is high. But if you know my normal voice, then only you will be in a position to understand whether I am happy or whether I am angry. Now, when the corresponding audio file comes to police, then they won't know what is the normal speaking style of the person. So what we do is we take first few seconds of the audio for training, because normally when the conversation starts, the person will say that my name is so and so, and then he will just say hello, this, that. So first few words conversation is normally in the normal mode. So we use this normal mode conversation and try to extract the parameters and use it for training. And then further analysis will be done, further segments analysis will be done to find out whether it is angry, aggressive, happy, fear, or surprise mode. We also have given stress mode, because sometimes the culprit is in the stress mode. The police are stressing or compelling the person to give a statement. So in that case, the person goes in the stress mode. He's having fear, and because of that, he's giving the statement. So that mode also we can recognize. So sometimes when the conversation is there, no telephonic conversation, then there is a first ring is ringing, the bell is ringing, and then there is music, etc. You are supposed to wait, and then the music rings. So we have to isolate ring, music. We have to also isolate background talk if somebody is speaking in the background, and then we'll have to do the emotion analysis. So it is really challenging. In this case, we say that we are using the training on the fly. Training on the fly means for the same sentence, we use first few second speech as the a normal speech, and we just try to extract the parameters for training of the system, and then further segments are utilized for testing. The newly launched system is deepfake audio detection, and this deepfake audio detection is there are I will just tell you a few things about the deepfake. There are some companies nowadays, there are some sites wherein you can go and submit your, say, 10 seconds or 20 seconds of speech, and then you can give the text. You can write down the text and submit it to the system. On the next day, the system will give you the speech synthesized in your voice. That is a deepfake voice, because you have not spoken that actually. You have given the text. This text you have not spoken. You have just given the sample utterance, and based on that, the system has extracted your peculiar parameters, and then the system has synthesized your voice for the given text. So that is called a deepfake voice. So for deepfake voice, identification of the deepfake voice is really challenging. And actually, I will tell you that I was sitting by taking a magnifying glass in my hand, actually, not literally, but you can just say that I was trying to find out different parameters which can give me the indication that this is deepfake. But it was really a tough task. But we could come across, or we could generate a common platform which can identify whether it is deepfake synthesized voice using one site or using another site, or whether it is the really recorded speech. So the first product, deepfake audio detection, Anubhuti deepfake audio detection, AD 5000. This particular system is ready, and the first product will be sold to FSL Mumbai, Forensic Science Labs, Mumbai. So we can have all tests done automatically one after the other, and the detailed report is generated. So we have number of tests generated for identifying whether it is deepfake or not. We have used time artifacts filter, we have used frequency artifacts filters, then we have used silence discontinuity, we have used zeros discontinuity, we have also used histogram analysis, as I told you, for defect detection. The system also has a batch mode in the sense sometimes they get 4 or 5 test files at a time, and they want to run these test files one after the other. So they can do so by using our batch mode, right? This is the book that I have published, is Speech and Audio Processing. This is published by Wiley Publication, and this gives entire information related to speech and audio processing, like speech parameters and whatever complete information that I tried to give you is available in this book, Speech and Audio Processing. Now we also have so we have so many products in the audio. That is, we also have Anubhuti audio authentication, because sometimes when the police gets the audio, it may not be authentic, in the sense the corresponding audio, what the culprit may do is, culprit may cut some word from the audio, or culprit may try to attach one audio to the other. So in that case, it is the concatenation of two files, or there may be some manipulation done. Now, the system must find out whether any modification is done in the audio or not, or whether it is the clean audio. That is called as Anubhuti audio authentication system. Now, this Anubhuti audio authentication system detects if there is any joint, if there is any phase difference, if there is any phase discontinuity, that is, we have phase discontinuity, or if there is any frequency discontinuity, what we call it as the spectrum discontinuity, zeros discontinuity, then we have LPC discontinuity, Then what we have is the common discontinuity, and all these discontinuities are captured in the audio authentication system. And this is the means highest sold system. You can say this is for this system, audio authentication system, we have sold something like 20 licenses to Forensic Science Lab. Besides the Forensic Science Lab, we have the clients like Maharashtra Police, we have Maharashtra Cyber, we have Center of Excellence, Pune, then we have the NFSUs, National Forensic Science University. So all these are our customers. We have CBI. For CBI especially, I am telling you the interesting story. We have generated signature authentication system for CBI. So sometimes if there is a will and they want to find out whether the signature that is done on the will is of the same person, it is done by the same person or not. That is, they call it as authorship detection. So for authorship detection, what they do is they take something like 300 signatures done by the culprit. So culprit will go on doing the signatures, 16 signatures on one page. Like that, he will have to continue and generate 300 signatures. And then all these 300 signatures are to be compared, and then they have to find out whether the signature is done by the same person or not. So in that case, firstly, scanning all these 300 signatures using your computer scanner is a very difficult task. So what we have done is we have signature verification and authorization system, wherein we allow them to authenticate this signature. But before that, firstly, we will have to annotate all these signatures and take it in the computer. And this system also we have automated. That is, once the page is scanned, they will get all 16 signatures in the computer. Well, then they put the second page, they get all signatures in the computer. So after they get all 300 signatures, then we have the signature verification system. We also have signature authorship system where we use different parameters. Here also we have used histogram. We have also used wavelet transform in this, and using wavelet transform analysis, we can compare whether out of these 300 signatures the culprit has done, whether at least one signature is matching with the actual signature on the paper. If at least one signature matches, they say that yes, authorship is granted. Similarly, the signature verification also has applications in the banks. When we go to the bank, what they do is they have some stored signatures, and then they just manually, visually verify whether it is the signature is the same or not, and they just allow you to do the transaction. But now we have a system, and in this system, the system can directly declare whether the signature is matching or not. Signature matching means, I will tell you, the exact matching, 100% matching of the signature is never possible. You must have experienced that even though you are writing the signature number of times, every time the signature is different, slightly different. The size may be different, some line may be different, some curvature may be different. But we extract the parameters such that we can say that it is matching to some 90% extent. And then we can say that yes, he is the same author, or whether the signature is matching for bank purposes. So we have this signature verification system. In the signature verification system, we also have what is called a document analysis. Document analysis means you have to verify whether the signature, whether the handwriting is yours or not. So given the handwriting, they ask the culprit to write the same sentences or maybe different sentences using his own handwriting, and then they try to match the handwriting. So there are handwriting experts. To facilitate their work, we have also generated one system which will allow them to match the handwriting. So the handwriting matching system is also available with us. After that, we have entered image and video analytics. In image and video analytics, what we have done is, we have one system wherein we try to authenticate image and video. So nowadays you will see that on WhatsApp there are a number of videos. Those are there. Those are AI generated videos, right? Means actually it is not a true video, but it is synthesized using the AI tools. So the system must identify that whether it is AI generated or it is normally recorded video. So that is this task is done by Anubhuti image and video authentication system, AIVA 5000. Then we also have Anubhuti image and video analysis and enhancement system. We also are going to develop, that is not developed yet, but we are going to develop the system for deepfake image detection and deepfake video detection also. That is this AI generated videos, AI generated images. We have actually done many experiments and we are going to do it. But the system is not yet launched. So we'll have to generate number of methods to identify whether the image is normally clicked image by the mobile camera or whether it is AI generated. So there are a number of sites. You must have heard about number of sites wherein you just give the text. You just say that a boy is sitting near the river and he is reading the book. Then the system will generate the image of a boy who is sitting near the river and reading the book. So you have to just give the text and it synthesizes the image. So text to image synthesis is also there. Text to video synthesis is also there. So this is, sometimes it is useful for some good task, but people are using it for means their bad intentions. So that is not good. So if they are using their intelligence for generating bad things, we will have to use our intelligence to detect those bad things. And we are trying to detect these bad things, those they are generated, and trying to help our police and what you can say, forensic labs, forensic domain, to identify all these culprits, identify different fake things that they are doing. So this is a very interesting stuff, interesting work, complete audio forensics, image video forensics, and we also have done signature and document forensics also we have entered. So complete spectrum of products is ready with Anubhuti Solutions. I would like to tell you that this work has come to me like it is decided and given or assigned to me by God. It is just directly assigned and God is saying that you do this and I am doing it. And I am doing it means God is helping me to generate the solutions and we are generating excellent products. And people are completely praising our products and they are useful to them, and they are now demanding only the products from Anubhuti Solutions. So I am proud to tell you that it is highly in demand and all these products are backed by the patents. Those are granted. So I have 6 patents granted, and all these 6 patents, they guard the different products those are generated by us. So it is a proud moment for me, I can say, but not what I have. I will not say that it is done by me. It is generated by God. He has given me the instinct. He has given me the intelligence, and I am using the intelligence provided by God. That is artificial intelligence, you can say, and I am generating these products. So this is how the miracles can happen. I was working in Rajashri Shahu College for 12 years and 6 months. I was working in Walchand College for almost 28 years. and I had completely the teaching experience only for about 42 years. After the actually I was prepared before the retirement only as to what should I do after retirement. So after the retirement, immediately I started with the work. But this is the God's wish, I will say, and I could generate such full range of products for the forensic domain. I think I will wait and I will allow you to ask some questions if you have, so that we can have better interaction.
Dear participant, have you any question? Then you can ask or write in the chat box.
Participants can unmute and ask questions.
Was it understood or it was little high for you to understand? What is it? I don't understand.
No, ma'am.
Did you find that the lecture was good?
Yes, ma'am.
There
was
Ma'am, one question, madam.
Yes.
Madam, what AI tools, not only for voice processing, for video processing, which
I am
AI
the,
tools will be
I am
beneficial for
not
research?
I am not using any AI tool. I am trying to extract the parameters and I am trying to myself provide artificial intelligence to the system, because ready-made AI tools are not useful for any kind of applications. Ready-made AI tools will give you 98% result on the training set of data. But if
Yes,
the data is outside the training set, it gives something like 50 to 60% accuracy. And in case of forensic domain, the data will always be outside the training set, isn't it?
Yes, ma'am. Yes. Okay, ma'am. Thank you.
Yes. You can ask any question. It can be. I will answer it.
Dear participant, you can ask any question. Or you can write in the chat box.
Yeah, you can write. How many participants are there?
Ma'am, it's almost 100. 100. Now it is showing 112.
Okay. But they must be having some questions, isn't it?
Hello.
Yes.
Yeah, good afternoon, ma'am.
Good afternoon.
Just one query related to the pitch processing. In
Yes.
certain cases, generally a researcher used to create a data set by lively recording.
Yes.
In that scenario, one query comes in a mind, yes, there is on a back end, there is a noise removal procedure that has to be taken care of. But apart from that, how we can deal with their emotion, if we are talking about the emotion, as you said in the session, someone if talking in some other tone, so we treat it as a angry from the pitch, right?
Yeah, it has to be relative, isn't it? Means my normal pitch is so and so, and if
Yes.
it goes above certain level, then I can say that the person is angry, isn't it? Because my tone and other person's tone will be different, so it has to be training on the fly.
Yes,
In case
but
of forensic domain, the noise cancellation is not allowed. If you do noise cancellation, they say that you are tampering the file. You are tampering the evidence. The evidence as it is to be utilized for whatever exploitation. Yeah.
But in order to develop such research, obviously get something innovative. In that scenario, as I said, some researcher used to create the data on their own. Instead of taking the normal data, actual data, live data, they used to create. So some person used to sit in front of them talking into the mic with different tone, and then
no,
those files accordingly.
that won't help, because if you, we also tried that actually. I will tell you that before starting the experimentation, we were also thinking that how we can start with the experimentation unless we have the data set. So there were some interns with me, working with me. So I asked them to generate the data set. So I had given some sentences and I told them that you can record the sentences, same sentence in angry mode, happy mode, and like that. They like this is a normal way of doing it, isn't it? So we also recorded that, but it doesn't help, because whatever tone or whatever emotion that you try to inculcate while recording the sentence is not the true emotion. You will have to get the actual, actual emotions you will have to get. So we worked on call center files. We could get something like 600 call center files. This actually emotion detection project was, means raised by one call center company, and it is in Canada. The company is in Canada, a Canada-based company. They asked me to ask us to develop this emotion detection system for call centers. So actually we could get 600 call center call files, that is customer care and the client. And when the customer, customer is not satisfied, the customer gets angry spontaneously. So initially he is speaking, I am so and so, then he will say that I have purchased this. Then once he starts talking, the person gets angry, and then you have to catch actually that angry mode. So those actual files helped us rather than the systems, recording the system.
Right. So good source of data, I came to know where I can get the realistic data through this.
Yes, and call center files, they're real files.
Thanks, ma'am.
Yes.
Ma'am, I would like to know which softwares did you use for such forensic applications?
Software means we are using Python, and we are developing our own code in Python. The algorithms are also developed by me only, so they are patented. So no ready-made tool, no ready-made AI model, nothing. That is why it is patented. Otherwise, if you use some ready-made tool, no, they will say that this is already available in the market. So what are you patenting? Isn't it?
Okay.
That is it. Yeah, and it does not give the results also. That is a more important thing. If you use the ready-made tools, there are many companies, big companies. I will not tell you the names because they may say that you are spoiling our names. I don't have any such intention, but big companies, they are trying to do it using ready-made tools. There are some hundreds of employees and they are working on the same task. They are using ready-made tools, ready-made models, and they are not successful. And they are asking me what you are doing and how you can make the successful system which is working for the forensic lab also. Then I said I did it myself. I did not use any ready-made tool. That is it. So hundreds of people, they are working on the same thing. The deep fake detection, no one is successful as of now. And we have launched the product and we are directly selling it to Mumbai FSL now. So it's means the unique product of its kind. But it is not mine. I can say Krishnarpanamastu.
Is there any questions, participants?
Madam, you can give my mail ID also to them.
Okay,
You can
ma'am.
share mail ID to them so that if they want to interact, they may not be in a position to ask questions right now.
Okay, ma'am.
But they may contact me, communicate with me on mobile. Anything they have written on the chat?
No, ma'am. There is nothing.
Good
Everyone.
afternoon, Apte madam.
Yes.
Apte madam, Jadhav sir is here. BD Jadhav.
बोला सर.
नमस्कार, काय म्हणताय?
असं चाललंय बघा, एकदम पॅक्ड शेड्यूल आहे.
येस.
हा.
नाईस टू सी यू. तुम्हाला ऐकलं पुन्हा एकदा.
हो.
Yes, ma'am. We can, ma'am, we can share your mail ID, everything on their FDP group.
Yeah. They can communicate. They can ask their questions. Okay, no problem.
Okay, ma'am.
Hmm.
On behalf of ENTC department, I would like to extend our heartfelt gratitude to Dr. Shaila Apte ma'am for her enlightening session today. The Apte ma'am, your remarkable expertise and decades of experience have truly enriched our faculty development program. Your insight into artificial intelligence for speech forensic were both inspiring and thought-provoking. Your ability to present complex concepts with clarity and connect them to practical application has truly enriched our understanding. The practical example, case studies, and innovative approaches you share have sparked new ideas and direction for all of us here. Once again, thank you, ma'am. Dr.
Thank
Apte,
you.
ma'am.
Yeah, thank you.
Dr.
Thank you
ma'am,
so
for
much.
your valuable time and for being an integral part of this program. We look
After so many days, I'm talking for 1.5 hours. When I was in Rajesh Shahu College, I regularly used to talk for 2 hours, isn't
yes,
it?
ma'am.
2
Yes,
Yes,
hours
ma'am.
lecture I used
madam,
to conduct.
you can. That is the spirit and energy with you.
Yes,
Yes.
ma'am.
I
That's
was
there.
little doubtful whether
We'll
I'll
be
be
very
in a
happy to
position.
see you in once again college.
Yeah.
भेटू एकदा.
Thank you,
Yeah,
madam,
नक्की,
for coming
नक्की.
for the session.
Yeah.
Here is
Yeah.
Dr. Swati Visikar, ma'am.
Yes. एकदा भेटूया म्हणजे
Thank-
सगळेच मला
Yes,
भेटतील
sir.
प्रत्यक्ष.
Yes, definitely.
येस. छान वाटलं.
Thank you,
भेटूया
ma'am.
नेक्स्ट वीक मध्ये मॅडम. नेक्स्ट मंथ मध्ये फेब्रुवारीच्या फर्स्ट वीकला आपण एक भेटूया.
बघूया ना. हो,
प्रोग्रामला
चालेल.
आपण बोलवतो. मला आपल्याकडे
हो.
इनोव्हेशनची ऍक्टिव्हिटी पण आहे, त्यावेळेला मग भेटूया.
बर चालेल ना. चालेल, हरकत नाही. ओके.
थँक्यू मॅडम.
Thank you, ma'am.
Thank you and
Dr.
see you
Vagas.
again, ma'am.
द्वागत सर. तेच
थँक्यू.
म्हटलं सगळेजण एकदा भेटतील.
Yes.
यायलाच पाहिजे
Yes.
एकदा.
फिजिकली भेटूया.
हो, खरंच आहे. चालेल.
Okay.
नमस्कार. तुम्हाला कसं वाटलं? म्हणजे समजायला खूप अवघड गेलं असं नाही ना झालं?
No, ma'am. It will start from basic, so it's clear.
Yes, I tried to do that because Visikar madam told me that what is the cross section of the audience, so I did it accordingly.
Yes.
मॅडम
It was informative, very nice session, ma'am.
Yes.
मॅडम मी पळगली मॅडम बोलते सांगलीतून.
वा.
तुमची स्टुडंट आहे मीची.
माहितीये मला.
छान झाला सेशन मॅडम, मी ऐकतेय.
हो, वा. छान.
छान झाला. थँक्यू व्हेरी मच. खूप
म्हणून मी तेच म्हणलं, कोण आहेत ऐकायला? तर दिसत नाही ना कोणी, त्यामुळे मला जरा वाटतंय कोणीच दिसत नाही मला.
सांगलीतून आम्ही दोघी आहोत. मी आणि दुसऱ्या एक मॅडम ह्या पूजा पाटील म्हणून आहेत त्या. आम्ही दोघी आहोत. छान झाला सेशन. भेटू मॅडम. आम्ही पण पुण्याला आलो की भेटू
तुम्ही
तुम्हाला.
पुण्याला आला की माझ्या घरी या. म्हणजे
हो मॅडम. नक्की. थँक्यू व्हेरी मच.
ओके, थँक्यू.
Okay, thank you, ma'am.
Okay.
Now the next session will hand over to Dipali. Dipali, are you here?
I will stop sharing. Huh?
Yes, ma'am. Yes, ma'am.
Yeah. And I will quit the meeting also. Yeah.
Okay, ma'am.
Yeah. Thank you so much.
Yes,
Thank you, ma'am.
ma'am.
Thank
Thank
you.
you,
I
ma'am.
got a feel that I could meet all of you.
Yes.
Yes, definitely,
Yes.
definitely, ma'am. We'll meet in the next month, first week.
स्वप्नाली तर मला दिसली.
Okay, ma'am.
Thank